So let's go. So thank you everyone for joining this event as well, and specifically for this session. My name is Ray. I'm very happy to be here today. I'm based in New York City, and it is 1 a.m. So I apologize if I don't finish my session properly. So I'm a developer advocate for the Google Cloud Platform. What that means is I love to bring some of the latest and greatest technology that Google and Google Cloud has to offer to developers all over the world. And I love to get your feedback and learn about your experiences as well. So if you have any questions, any thoughts, any feedback, please contact me on my Twitter account at Scientism. It has the highest interrupt. That means that if you have any question, ping me there. You can direct message me, and I'll be happy to help and answer. All right. Very briefly about Google Cloud Platform, we have anywhere between infrastructure as a service for virtual machines all the way to platform as a service where you can just deploy your code. We also have a range of big data and machine learning services. If you want to learn more, check out cloud.google.com. Okay. So this section is talking about gRPC, which is a remote procedural code framework. But why do we need to talk about binary protocols, and how do we get here, right? Currently, there's a trend where we are able to break down a monolithic application, or trying to break them down potentially into multiple microservices to solve specific problems that you may have, right? For example, scaling issues, or the need to be able to iterate faster and deploying individual functionalities into production environment without having to go through and change all the other parts of the system. There is a trend of going into microservices to solve some specific problems. Now, whether you need it or not, I think that's a separate talk. But there's no theory here. If you have decided that you do need microservices, you're gonna face a few issues first, right? Well, number one is that once you have broken out the services, you now have more applications and more instances that you need to deploy and manage, right? Traditionally, we have one single instance for one app, right? And then we scale that out to multiple instances, but it's still a single package you manage. And now we may need to go, break these things down into multiple components. And all of a sudden, if you have, say, 10 components and 2 instances of each, now you are looking at managing 20 components, right? And you gotta be able to deploy them, you gotta be able to manage them. But that's okay now because we have the technology to orchestrate these microservices fairly easily with the lower overhead by using tools, orchestration tools like, say, containers and Kubernetes that you can use to manage multiple instances of your app. But there's one thing that most people don't think about a lot is that, well, how do you actually communicate between these services in the backend, especially? I think that we have been using RPC before, and for some reason there was some bad rep around RPC in the past. So the history has, occurred, and then we kind of moved on to say, you know what, I think that JSON over HTTP is probably the default protocol that we fall back to. And it is easy to use, and quite a lot of people know and understand how to use it. But when you look at your backends, is that the right technology, and does it support the scale that you need? Is something that you may have to consider, right? So this communication is what we need to consider in this session. Like I said, RPC sounds a little familiar. And why are we talking about it? I don't know if anyone on the call kind of remember the old days of Corba. Every time I do a poll in a real session with people in front of me, I would be like, hey, how many people have used Corba before? And there are always quite a few people who raise their hand. And then there's like, well, how many people are actually using it today? And there's always, again, quite a few people who raise their hand. But overwhelmingly, Corba has been thought of as something that's harder to use and slightly more complicated. And then some people have used DCOM. And for Java, we have RMI, which is usually a lot simpler to use than the other technologies, but it may not be as interoperable as some of these technologies, right? Because the server side and the client side, they both most likely needs to be using the Java language or running in the JVM in order to use RMI. And to make these services more accessible across multiple platform, what happened then is with SOAP, right? We used a XML format so that it can be machine readable and human readable, kind of, by different platforms. And then we can use the WSDL potentially to generate the clients for different platforms as well. It typically worked in an interoperable environment. But the problem with this is, of course, like sometimes you might find the protocol extremely heavy, and it's going to eat up bandwidth and CPU usages when you try to transport these objects around. So what happened? Why RPC? Well, because of all those issues, I think today, again, most of the transport are now just using JSON over HTTP, which is kind of the default fallback. But then why RPC? Well, to me, RPC has certain advantages I like. Specifically, I am a Java developer myself, and I like strongly typed things. I like to be able to have the static type checking when I'm writing my code before I run it. So with RPC, usually there's a way to define your model, or your payload, or your messages. And then there's a way for you to define your specific operations, so that when you're constructing and reading these objects that's being passed over the wire, you are able to depend on the marshalling and marshalling system to do the right thing. And in the end, you should be able to just reference to these strongly typed objects. However, there's more to that, right? Because in REST, most of the operations are kind of limited to the HTTP verbs. So you have to deal with the get, the put, the delete, the patch, right? But these are usually dealt with a CRUD program where you're accessing data, you're reading data. What it sometimes fails to be able to express is the ability to express like an operation where you do need to perform multiple calculations or multiple transactions. And for example, if you need to deduct money from an account, yes, you can possibly do that with a RESTful representation or a RESTful operation. But in most cases, it's going to be like, well, how do you make sure you deduct only this amount of money? And it's not really a delete, right? You don't delete $10 from your account. You can't update in, just say -10, right? So what are you doing in those situations? And RPC is really nice in terms of being able to define these operations very explicitly, and then people can code them with these strongly typed services and stubs. But RPC will only work if it's simple to use and interoperable. And that is the goal of gRPC. At Google, internally, for our backend, we use a framework called Stubby. And Stubby is an internal framework for us to do binary-based transport for our RPC calls. And today we do 10 to the 10 RPC calls per second. And that's about 10 billion RPC per second, which is quite a lot of volume. And if you put this into context, right? If one of these RPC calls is going to take 1 extra byte, that's just unnecessary extra byte, then that's like 10 to the 10 byte more that we have to handle within our data centers, within our network. So what the people have done here is to make sure that Stubby is efficient over the wire, and also performant. So what is gRPC? Well, gRPC is literally the open source or the next version of Stubby. And this came about when Google wanted to open source Stubby, and when another company, Square, wanted to explore the next generation RPC framework. And so what happened then is that the two companies, the two community joined together and then say, hey, why don't we work on this together? And this is where gRPC came about. And gRPC, the G in gRPC does not stand for Google. gRPC is actually a recursive acronym. So gRPC stands for gRPC Remote Procedural Code Framework. And it is fully open source, and it's got a vibrant community. And part of the reason why I love to spread the word is that we are looking for people to contribute to the community, whether using it or contributing to the code base and participating in the forum. Let us know how we can make this even better through the open source process. Now, gRPC is simple to use. It's based on standards that's performant. And most importantly, it's interoperable. And we'll take a look at how we achieve that, right? Well, first of all, gRPC does use an IDL, or interface definition language. And for that, we're using protobuffer3 language so that we can define our payload and also our services in a canonical form, and then so that we can generate stubs and generate the code for different languages behind the scenes. It is also based on standard technology like HTTP2. Now, HTTP2 is interesting because, well, it is the new version of HTTP, but it's also more performant and more efficient. For example, HTTP2 is binary based. So traditionally, when we make an HTTP call, right, you can see the plain text of that. And all of those characters are going to take up quite a few bytes. Like get method is going to take 3 bytes just for the get operation, specifying that, right? In HTTP2, all of these operations and methods are going to be encoded in binary. Moreover, a lot of the traffic that's going over HTTP are actually not just the payload, but also the header. People store metadata information in the header. For example, where did the request come from, and what authentication headers do you need, etc., etc. All of those things goes in the header. In some cases, the header can be quite large. In HTTP2, we can actually compress the header by using HPAC. So again, we gain efficiencies over HTTP1. Moreover, in HTTP2, it supports multiplexing. What that means is we can have multiple streams. We can multiplex multiple streams, multiple requests over a single HTTP2 connection. And then what that translates to is that rather than being the need to open up multiple connections for every object that we need to download or for every gRPC calls over HTTP2, we can have multiple streams going over a single connection to cut down the TCP overhead. In HTTP2, streaming is also built-in and native. In HTTP1, we have to deal with it with the WebSocket, but in 2, streaming is native, and not only can you do client-side streaming, you can do server-side streaming, and you can also do a bidirectional streaming, and that's native concepts in HTTP2. On one really interesting use case, for example, is that when you're requesting an index page, rather than waiting for the client to pull and tell the server, okay, this is the index, I need to download like the CSS and the images, right? The server can actually proactively push these objects to the client if it knows the client needs it, right? So the client doesn't have to wait and request it retroactively. The server can push these things actively. And finally, the payload is based on protobuffer3, and it is an efficient marshalling or marshalling protocol, and also that it encodes the data in an efficient manner. Okay. Very quickly before I jump into the demo, the difference between the two, for example, in terms of performance in gRPC, you can see the throughput is quite a few times more than JSON over HTTP, and that's partially also because not only gRPC is more efficient in terms of transporting data, but also that the binary protocol allows it to parse and marshal and unmarshal data much faster. And what's even more interesting is that as we're moving to, say, cloud-based workloads, so for example, if you're deploying your application on Google Cloud Platform, you're going to find that in cloud providers, right, we charge a lot for, in most cases, for the CPUs, right? So what you want to do is to reduce the CPU usages or make the most use of your CPU. And in this case, you can see that per CPU, gRPC can outperform the traditional way of doing things like JSON over HTTP by magnitudes of scale here. So it's something that you really want to consider, especially if you're doing a backend to backend communication. It supports today 9 different languages, but I want you to pay attention to 3 of them: Objective-C, C#, and Java. Now, aside from PHP, Python, Ruby, Node, Go, and C++, these 3 are pretty interesting because these are also the languages that are used for mobile platforms. So gRPC can also run on mobile. So you can actually run a gRPC client on the iPhone, the Android phones, or the Windows phone by using these languages. And the benefit here is that because the payload are more efficient, if you're writing mobile applications, this could make that user experience a little bit better by transporting less over the wire and over the wireless, or being able to use less processing power to decode and encode the messages. And ultimately, hopefully, this is going to translate to a lower latency, more throughput, and also better user experience and response time on the UI. And finally, hopefully, being able to use less battery. Okay, so let's see how this works. I know we have 45 minutes sharp, so we got about 25 minutes for some demos. So I'm just gonna jump into the basics of gRPC so that you can see and feel what it is like to be using it. So the first thing I want to do is to create. Oh, there we go. Let me hide that. The first thing we need to do is to create the IDL, the interface definition file, and for that we're going to be using a proto file, right? And so here's where we can define our message payload and also our RPC service in a canonical IDL. And to do that, first of all, I need to set the syntax to Proto3 because that's the language, the syntax we need to use. And then we can define our payloads first. And to do that, we can do a few things. So for example, I can specify a package. Just like a Java class, I can say this is a com.example.grpc package, so I can do that. Now, these files are going to be translated by a generator. So there's a Proto-C generator that's going to read this file and then generate the output for different languages. And we can actually specify some options when the generator is generating the files. So for example, in Java, by default, it's going to generate all of my files into a single, all of my classes into a single Java file, for example. And I don't like that. So I can tell the generator a different option. So I can say Java multiple files is equal to true, right? So by adding this option, when I'm going to generate my classes, it's going to belong to a separate class file, which is the way I like it, all right? And then we can go ahead and generate or define the message or the payload. So in an RPC request, a simple like what we call unary request, we will have a single request and a single response payload. So first, let's define the request. So I can do like a hello request, and then I can specify the fields, which is pretty straightforward. So I can say there's a field called name, and it is strongly typed. So we have a range of different default types we can use. You can also define your own types. But here's the interesting part. Rather than just defining the name like that and be done with it, we need to assign it a tag. A tag is important. This numerical value is what you need to explicitly assign to a field. And this value is actually used as the marker for this field over the wire. So this is where we gain a lot of efficiency, right? Over a text-based protocol with with JSON, for example, we have to repeat this field name over and over again. In gRPC, we just use a byte to encode this value, and we send that byte over, and that's it. So rather than sending 4, now we're just sending 1 byte, for example. And we apply this to any of the field that we use here. Now, here's the beauty of this. Now, if you actually change the name of the field, as long as the tag stays the same, it's going to mean the same thing when you send the data across the wire, okay? Like I said, it's strongly typed, so I can do something like age is equal to 2. We can also do lists. So for that, we can specify repeated string. Say, I don't know, hobbies, for example, is equal to 3. And we can also create a strongly typed max. So just like Java, where the key and the value are strongly typed, or in gRPC, you can do very similar things. So I can name this bag of tricks, for example, to 4. And live coding on Hangout is definitely not my bag of tricks. So let's see how this works. What's also interesting is you can specify enumerations or enums. Just like Java, you can specify enums. So can you do this in gRPC? So I'm going to specify a enum called sentiment. And I'm feeling OK right now. I'm feeling pretty happy. So I'm going to say there's a sentiment called happy equal to 0 for now. You could be very sleepy, hopefully, especially if you're in New York. It's 1 a.m. in the morning. You could be sleepy right now. And some of you, hopefully, are not the case, but you could be extremely angry at me towards the end because you see how easy it is to use gRPC. All right, so let's do that. So now we have sentiment, and we can just use the type here and give it a tag. And that's how you define these requests. I can do the same thing for the response. So I can do greeting is equal to 1. Okay, and this is make a simple hello world service here. Okay. Finally, we can define the service. So to define the service, all we need to do is to use the service keyword, and I'm going to say greeting service. And then I can define different operations in this service, right? When it's all generated, like all of these messages are going to be turned into like a class, like hello request class, and the greeting service is going to become a greeting service class, and then all of the RPC methods are going to become methods in that class. So I'm going to say greeting. I'm going to taking a single request, and I want to return a response. And that's it. That's all I have to do to define my payload and define my service. Of course, I can have more operations here. And moreover, if you want to receive a stream of these hello requests and only respond to a single hello response, all you need to add is the stream keyword to the request. If you want to do server-side streaming, where you need to return from the server a stream of responses, then you just add stream keyword to the response. It's that simple. If you need to do bidirectional streaming, where you need to receive a stream of requests and respond with a stream, then you just add stream to both ends, and that's all it takes. But for this one, let me keep it simple for now. I just want to do a simple request and response, so I'm going to just do that. All right. So that's pretty straightforward. Once we have defined the IDL, what we need to do then is to be able to generate this into actual Java classes and Java objects. And there are different ways you can do this, right? The first thing is that you could download the generator yourself from the website and then run the command line yourself. But I don't really recommend it because you have to find the right version of the binary for your specific platform, and then you got to figure out all the command line. You know, rather than doing that, what you can do is by using the plugins. Now, if you go to gRPC homepage here in github.com, gRPC Java, we give you some pretty straightforward getting started here. So depends on whether you're using Maven or Gradle. We got instructions there. So I'm using Maven right now. So let me first add dependencies. So let me do that. So these are the libraries I need to run gRPC. However, for generating the objects, rather than downloading all of these things manually and running these things manually myself, I can just run a plugin. And the nice thing about plugin is I can also tie it into my build phases, right? So whenever I'm doing the compile, I also want to generate the code before the compilation, right? So I can do that. And also pretty neatly is that we can detect the operating system you're running on so that we can download the right binary for your operating system here, which is kind of neat. If you're using Gradle, you can also do something very similar by using the Gradle plugin here, okay? So I'm just gonna copy and paste this in, and that should be it. That should get me enough to generate this. So let me go ahead and do this. I'm gonna do a Maven clean, and I'm gonna do a Maven package, okay? So what this is going to do, hopefully, it's going to compile my profile and generate the code. So if I go to target, and if I see generated sources, I can see that protobuf directory there. And this is actually the code that's being generated by the plugin, which in the backend, it actually codes the generator. Right? So I can see the hello request and hello response. Pretty neat. So that's good. So now I got the stubs for the servers. I have the payload. Now all I need to do is to implement the server, right? And that's pretty simple too. I don't know if anyone here implemented the Corval or DCOM server. It can take quite a few lines of code, and in gRPC, it's actually quite straightforward. So the first thing I need to do is to implement my my service. So I can do something like public static class and greeting service info extends. And it actually generates this base class for me that I can extend. And from this abstract base class, I can go ahead and extend override the method for my operation. So in this operation, you can see that from my IDL here, which says RPC greeting with a request and response, it generated the method that looks like this, which is greeting request. Now, it actually caught me by surprise at first. Is, well, I'm returning just one response. Shouldn't the hello response be in the return value? Well, on the server side, gRPC Java, we promote the fact that on the server side, all of these operations are going to be performed or can be performed asynchronously. So rather than returning something which will make this a blocking call, the way that we return asynchronously is by returning via a callback. So the stream observer is literally a callback. So that is, you can think about this as a reference from the client, where I can then call, and as soon as I call this callback, it's going to send the data to the client, right? So this is what we can do to implement this. For example, I can, first of all, I can print out the payload to see what's inside. This is nice because the generated code actually implements toString and it formats the payload nicely. And then we can create a greeting string, which is like hello. And I can get my request. And I can get the name. And again, all of these getter methods are pre-generated for you as well, based on the IDL. So I can get a name, which is nice. And then now I can construct a response. Okay. Now in gRPC, all of the objects that you're going to be using are going to be built by using builders. So it uses the builder pattern pretty extensively. Okay. So to create a response, you would need to use a builder, and in the end, call the build method, and that will give you the generated object here. So in this builder, I can go ahead and set my values. And because I only have one thing, I'm going to just use that. Okay. And finally, for me to send this data back, again, rather than return, right, which will make this a blocking call, we are going to just use the response observer, which is a callback that I can use. Now, this callback has 3 methods that you can use. If you look closely, it kind of reflects the RxJava stuff, right? It's actually like observer. You have the unnext, which is what you can call to send the data to the client. When you are finished with this operation, you can call uncompleted. If you do have an arrow you need to pass back to the client, then you call onArrow. And these are the 3 ways for you to tell the clients what's happening. So for me to return the response, I'm going to do that, unnext response. And that will take this object and send it back to the client. Now, very, very importantly, you do have to call the uncompleted. We are done with the operation. If you don't call this at the end, the client will continue to wait for more responses or continue to wait until the operation has completed. Okay, so even though this is only expecting 1 value to be returned, you still need to call uncompleted here. All right. So that's my implementation. It's pretty straightforward. And now I have to start a server. I have to listen to a port and make sure that my server runs in the background, right? And to do that, what do? Well, we need to create a server object. And to create a server object, well, all we need to do is, again, using the builder. Builder pattern is being used quite a lot in gRPC. So I can say I need to build a server that's listening on port 8080. And in this server instance, I need to serve the greeting service. So I just go ahead and say add service and greeting info. That's the implementation I have. And once you're done building and configuring your server, just call build. Once you have the server reference, you can call start it. But here's the thing, the server is starting in the background thread. So if I don't do anything here, this main method will just quit and exit, right? And nothing will be listening. So what I need to do is to just wait for the server to be terminated. So now I'm blocking the main thread here, okay? So hopefully with that, this whole thing will work. So let's try it. So I'm gonna go ahead and do a Maven install. And then I'm going to use exec.java plugin to just execute this server process and see if it actually starts. Wish me luck. No, well, I think it's working. Since I'm not printing anything. So my server daemon is working. It's listening to requests right now. Fantastic. The next thing I can do is to make a client. And this is also pretty fun to do. How do I actually connect to this service, right? Well, all of the code is generated for us already. So we can get access to this stuff very, very easily. However, we do need to know how to connect to the server. So from the client side, the way that we connect to the server is by using the construct called channel. Now, rather than dealing with the underlying TCP connection or the HTTP2 connection, we abstracted all of those low-level things away. And so the only thing you need to deal with is called a channel. Okay. So first of all, we need to open the channel. So I can create a managed channel, which is what we need. What we will communicate everything through the channel, right? And how do we create a channel? Well, we can use a builder. There you go. So with the builder, I can say I need to connect to localhost, for example. And I believe I need to specify the port here. Yeah, there you go. And because this is running on my local machine, and I really don't like to deal with certificates, my Java application. So for the meantime, I'm just going to be using plain text. So I'm going to go ahead and say plain text is equal to true. And here, when you're building the server, you can specify quite a few things. You can add interceptors. You can add executor service here. But very, very importantly, if you're running these microservices, right, you need to do two things, right? First of all, you need to be able to resolve a logical name into multiple, potentially multiple serving endpoints. If you're running 10 instances of your server, maybe you want to refer to it with the logical name hello service, right? You need to have some kind of service discovery. You need to integrate with that, whether it's Eureka, Console, Zookeeper, whatever. So for that, you can implement a name resolver. So a name resolver will be able to take a logical name and then turning that into a list of endpoints, right? And then you can integrate with some of the backends. What I have done is to integrate it with, say, Spring Cloud Discovery, so that given a logical name, I can use Spring Cloud Discovery to resolve the endpoints. And then you can also specify the load balancer, of course, so you can perform like a round-robin client-side load balancing if you want to, right? So let's just do that. Let's just build a channel like that. And now we can connect to my local host on port 8080. Once you have the channel, then you can use the channel for the stubs. So for example, the stub is already generated for me. So I can go ahead and do greeting service info. Sorry, not that one. Let me take that back. Greeting service gRPC, right? And then I can say new stub. Now here's interesting. I can create 3 different types of stub. This is nice because remember, on the server side, I implemented everything via asynchronous interface, right? And now on the client side, I get to decide on whether I want to make the call as a blocking call, or if I want to make the call as an async call, or do I want to get a feature back and then play with the features, right? So it's nice it's up to the client to decide how this should work. Now for this command line application, I'm just going to use a blocking stub, and I'm going to pass in a channel here. And then I can assign this to a stub like that. And now I can call the greeting service right here, the greeting operation. I can construct my payload with a builder. I can set my name, Ray, set my age, 18, let's say, and then view the object, okay? And this is going to give me a response. And I can go ahead and print this out, response right here. And that should give me that's all it takes for me to open the channel and then make the call and get a response back. So let's try it. So I'm gonna go ahead and run this the first time. Let's see if it works. And it opened the channel, and here's the greeting message I got back. And if I go to the server, there it is. I can see the payload, which is what I sent, which is nice. That was really easy to do. Now, gRPC also have a few very nice features. For example, I can set deadlines. So one thing that you may notice is that when you're making all these service calls to the backend, you may not want the client to wait forever, right? Because if the operation is going to take too long, the client may not need to wait. You might need to set a timeout. Now in gRPC, the concept of what we call deadline is built in. So what I can do here is that with this stub, I can say with the deadline, right? And I can say how long this operation should take. And if this operation takes longer than say 500 milliseconds, then you're going to get a deadline exceeded exception, so your client can move on. It's also going to cancel. You can also cancel the operation on the server side. And most importantly, the deadline can be propagated to all of the child requests as well. So for example, if you have a top-level service that makes multiple nested calls to other services, the deadline is applicable to not just the top-level service, but also all of the subsequent calls across boundary. So that's pretty neat. You can also propagate context. So for example, you can propagate the what you call it, the user IDs, for example, or a trace ID to properly trace across multiple codes. Okay, so that's a very, very simple and straightforward example. I do have a few minutes, so this is what I'm going to do. I'm gonna do this rather quickly. I want to do another example where we can do bidirectional streaming, right? So I have the portal file here defined. I'm going to build a chat server, and I'm gonna be able to hopefully have a chat over a JavaFX user interface. So this is the portal file that I defined, and again, the takeaway here is that to do bidirectional streaming, all I need to do is to add the string keyword here to my request and to my response. Okay, and then I can go ahead and implement the server. Now, this is a little bit tricky because you have to understand the return value and the request here. Okay, so the request here, remember, is the callback. The request parameter here is what I need to call to send data to the client. What the client sends me is going to be received via a callback that I return to the server. So in order for me to implement this, I'm going to go ahead and return a new stream observer, right? And that's going to get me a few multiple methods here. I have the unnext, unerror, and uncompleted, right? So whenever the client sends me some data, I'm going to print this in the unnext, right? This method is going to be triggered. So whenever I receive this, this is what I'm going to do. I'm going to send it to all of the other clients that's connected to me. And for me to do that, I'm going to do a for loop. I'm going to do observer and observers. And for each of the observer, which is the client that's connected to me, I'm going to call unnext, right? And the method I need to, the payload I need to give it back is the what I call the chat message from the server. And then, of course, I'm going to use the builder, right? That's pretty straightforward. I'm going to set the message, which is the message that just came in, okay? And that's all I need to do to send the data to all of the connected clients. If the client ever throws me an error, well, I'm going to do what everybody else does, which is do nothing. There you go. Or in some cases, you would want to, maybe do a clean stack trace. I guess that's what a lot of people do. But for me, I also need to make sure that my client is removed from my list, so I can do remove this specific observer, this specific callback reference. Same thing when something gets completed, right? Okay, so that's what I need to do to implement the server. Let's give it a try. Of course, I'm going to start the server here, and it's going to be listening on port 9090. So let's see if that works. So I'm going to run this right now, and let's see how this works. So here is the server running, and hopefully it's listening to my data. Now, the last thing I need to do is to implement my client. I'm using JavaFX, and it looks like that. Oh, where did it go? So it's got a name and the message, and I'm gonna click on send. That will send it to my gRPC service, right? So the takeaway here is that I'm still building the channel. I'm still calling, creating the stub, and I'm going to go ahead and make this call. And in this call, I'm going to send the server a stream observer. And now remember what this observer is doing. This observer is going to listen to the data that's coming in from the server. So whenever I receive a message from the server, this unnext is going to get triggered. And when that triggers, I can go ahead and update my UI. So I can say messages.add the string, which is the chat message from the server. I can get the from, and then I can go ahead and get the message itself, right? So I'm going to do that fairly quickly. Get message, get message. Okay. Easy, done. On arrow, do nothing as usual. And uncompleted, also I don't need to do anything right now. Okay. Now, what's interesting is how do I actually send the data to the server? Well, for me, if you see this response value, it's yet another stream observer, but this observer is actually the observer to the server. So to me, this is actually messages to server, right? And with this callback, whenever I say messages to server.onNext, that's going to send the data to the server. Okay. So for me to implement this, I gotta go ahead and listen to my click event in my send button. So I'm gonna say set on action. I'm going to listen to an event. And when somebody click on the send button, I'm going to use that reference. I'm going to call onNext. And remember, this is what I use to send the message to the server. I'm going to construct a new message here. And what's going to be inside that message? Well, I'm going to set the front field to the name, get text, and I'm going to set the message field to the message dot get text. Whew. And hopefully that's all it takes. So let's give this a try. So let me rerun this JavaFX application. Oh, what did I miss? I missed a semicolon somewhere, which is here, I think. Do you see it? There we go.
Ray, for some reason you switched the slides, so now we see your face.
I'm sorry?
For some reason your slides or your screen sharing
fell off. Did that end? Okay, let me come back.
So we see your face.
All right, let me do a screen share again. Sorry.
Amazing, but
yeah, here we go. There we go. Okay.
Thank you.
Yeah, these are good.
Oh yeah, we can see the code now. So.
Yeah, you can see the code now. Okay, very good, very good. Okay, so with that, we should let me do this compilation again. I'm almost done. 126. Oh, did I miss something? I think I missed something here. And I know we're almost out of time, so there we go. Message to server, and then I create yeah. Oh, what did I miss? I'm not quite sure, but that should work. And suppose that worked, then what's going to happen is if I run this client again, which there's a little arrow here, 75. What it should do is to be able to basically launch my JavaFX application and basically being able to send the data to my server. Okay. So I know we're out of time, Oleg. Maybe there's some time for questions while I kind of fix this code up a little bit. What do you think?
Yeah. We have a ton of questions in the RC chat, so I will go through them in no particular order, just in order they appeared in the RC.
Yeah.
So maybe you can clear some things for us. So first, a couple of people asked how does gRPC relate to REST and hey to us. So yeah. Sorry, what was the question? Sorry, my demo just worked, so I'm super excited about that. Yeah. How does gRPC relate to REST? So
REST,
the resource representation state transfer. So is it used instead of REST or?
So for example, REST, you're using the basically HTTP verbs, right? And you are kind of limited to that to make your operations. And in some cases, the operations are not easily expressed in REST. And also with REST, with JSON over HTTP, we're using text-based messages, right? So gRPC is, you can think about it as using a binary message over a binary protocol. In this case, the binary message is going to be protobuffer 3. And over the binary protocol, which is actually HTTP2. So you can literally think about it as, almost like you're making an HTTP2 request with a post that's using a binary payload. That's literally what happens behind the scenes. But of course, on top of that, we manage the connections for you, and also we take advantage of HTTP2 streaming.
Good.
Yeah.
So I think the same thing relate to HATEOS, like HATEOS, the hypermedia protocol. So you can extend that with binary messages, I guess.
Yeah, so HATEOS, you're right. So that's a way for you to represent resources, right? So in gRPC, you represent it directly with your protobuffer definitions, basically, and you can do additional reference to other objects if you need to. Yeah.
Cool. Another quick question. You enabled the option for Java multiple files.
Yeah. And
the protobuf generates you multiple files. So since you're not supposed to modify them by hand, what's the reason for that?
Oh, I see. Well, that's kind of my personal preference. You don't have to use it. For example, it's an option. But for me, I like to be able to see, okay, now if I need to find my hello request, like if I want to go see the generated source, for example, if I go to target and the generated source and see protobuf and Java, I like these files to be separately, and that's a personal preference. If you don't have that option, that's perfectly fine, and it will just generate into a potentially a single file, right?
Okie doke. Good answer. The next question is really quick. So we've seen your IDE support int64 type. Was it not in Java, was in Java, or was it there was just some sort of confusion happening?
This one right here. Oh, yeah. So you can do something like that. That's also a valid type in protobuffer as well.
Yeah, and that would not be like Java specific. Good.
Right, exactly. Yeah, it's not Java specific.
What security is used for securing the gRPC call?
That's a great question. So for the gRPC, with HTTP2, when you say if you don't want to use plain text, then it's going to be sent over the HTTPS string, right? So there's privacy. What we don't do is to add additional layers, except for if you need to add authentication or authorization, then what you need to do is by passing metadata or headers into these calls. And now these metadata can actually be propagated across multiple calls, whether the calls are in process or across server boundaries. So in gRPC, right, we can actually propagate the user ID across multiple calls, across multiple servers if necessary. And then you can apply the filter or interceptor pattern on the servers to perform some kind of validation or checks against these headers.
Cool, great. Another question comes from Rob Church. The question, is deadline propagation to child calls, is it automagical, or do we need to do some work in the service to chain them together so we can inspect or override the deadline being passed through?
Right. It's pretty much automagical. Yeah. You don't have to do any additional configuration for that. And also when you can also cancel server requests, and that can also propagate. So if you cancel a request, you can listen to these cancellation callbacks, and now you know your specific request got canceled, and it will cancel subsequent calls as well.
Awesome. And the last question also comes from Rob Church, and it's another great question, I think. So one advantage of HTTP is that the protocol is human readable. So we can TCP dump and look what's going on over the wire. So right. What options for debugging the interaction between services do we have with protobuffers and with gRPC? Right.
So that's slightly more difficult, I agree, because HTTP2 is going to be a binary protocol, so you need specific client for that. But moreover, the gRPC payload is also binary as well. So there are actually a few projects out there in the community, which actually I want to bring up. There's a growing gRPC ecosystem, and one of them is gRPC CLI, so that you can run a CLI and basically construct your message and then sending it to the server by referencing to a specific profile. And there are a few different of these type of projects out there, but basically it creates a easier, a friendlier interface for you to test out and interact with your service, so that you don't have to construct your binary messages every single time. And on that note, the ecosystem, there's another project called the gRPC ecosystem repository. And in there, you're going to be able to find some of the contributions from the open source community. Two of which I would really want to call out is for your microservices applications, right? You may want to do two things, right? One is you want to monitor your application. So for that, you can potentially use something like Prometheus. And there's a gRPC interceptor for Prometheus as well. And that's going to be able to collect some basic metrics through the interceptor pattern. Another thing that you can do is by perform distributed tracing across multiple calls, even across server boundaries. And for that, you can actually use Zipkin, right? I think Zipkin has been mentioned quite a lot for distributed tracing. And you can use Zipkin, and they have a library called Brave. And there's a Brave gRPC, which allows you to add interceptors to your client and also your server, so you can propagate like a single trace ID, and then let Zipkin being able to collect those data and then trace the code for you. Okay.
That's awesome. That's a very expanded answer. I think we have no more questions in the RSC. And with that, I would like to thank you, Ray. This was an amazing session. Don't you like when the demo just works magically? It's absolutely perfect. It's a pleasure to watch you do that. It's been terrific.
Thank goodness the demo worked in the end.
IRC channel was also buzzing with the comments and discussions. So I think it was a great success, this session.
Thank you very much.
So coming back to the couple of things that we do on those sessions,